Well, I'm Ardillo, Jeroen. I made a small bio, but since you didn't read the agenda, a small introduction. I'm one of the Random Data members, and recently I became a board member as well.
Yep.
Wait, you were bored?
Always.
Not as bored as you are.
Yeah, well, I do things with electronics. I do some Arduino workshop for beginners. All kind of things actually. Some 3D printing. I did some drone projects, flying things, and a RSpliet project. But I didn't do that alone. RSpliet, which he's in Germany, I guess, right? Still, yeah. And I started the project. And half an hour after the RSpliet meeting in June this year, and later on, after I think 4 evenings of hardware hacking and investigation, we were assisted by SYNNACK combustor voozl, and all together we did this project. We did this hack, so it's a joint venture, not a single man's work. We're all good at something, and I guess this is one of the good example of what a hackerspace can do when you come together and you decide to do a project in a team. So, RSpliet, for the ones who don't know the aTTYlas project, it's building the largest internet measurement network. And it's a good project, I think. You can get those RSpliet nodes for free. Free hardware is always good. And you can hack them. Right? Or you can use them and make it connect it to your home router, and then you can log in on a web interface and do some measurements on the internet or websites or the countries. A good thing, you can use it also with an API or just with a web interface for basics. And well, we got them after the workshop, after the meeting, and half hour after that, we just put one, we break one open. We opened one, and we did some searching on the internet. And there is a Russian site which did the same, but those guys only disassembled the probe, and that's it. Didn't do any good things with it, just opening it to see what kind of hardware was used. Well, we did the same first, but after searching we thought, well, what's in it? What can we use it for? What kind of software does it run? All kinds of things. Some pictures. I don't know what a new is for, but I guess it's
only in Russia.
Yeah,
inspiration.
It's also
Russian
a Cold War version, I think. A very old one.
You can inject probe in your body.
Yeah. So after opening it, it became clear that there's the inside of it is a Lantronix Export Pro. It's a very small Ethernet connection with a microcontroller on it, and it runs Linux. And there's development documentation for it. That's a good thing. So we decided to get a logic analyzer and connect it to the probe. And the developer documentation helped us with finding the right connections. It was a big help. So what we could do is monitor what was going on the probe when it booted. This is this is just the output of the software, the logic analyzer software, and you can export it to a comma-separated file. And together with this Perl script, thanks to Roy, we made this of it. This is more readable. Can you see it? Yeah, okay, it's standing. So we made a project page and we dumped our output on this page, so other people could read it. Well, after that, only the logic analyzer is just for reading, and we couldn't get an active connection with it. So we tried a serial connector, but this one was 5 volts, and the logic analyzer didn't have any check on what kind of voltage is used. So we just trial and error, and we used a 3.3 volts cable, which was the correct one, and that worked. Together with Minicom, we could enter the device, but we still didn't see anything specific. We didn't get any command line or just a root login. The only thing what we see was just output from the device when it was booting. But back to the documentation, we could see there was some kind of silent boot option on it, and well, we guessed that maybe it was active. But as friendly as they are, they said how to open it as well. So after doing this, we get this. And we could do some basic things. And this one is interesting. Show, where is it? Here. Show config. So, show me more, there was more information. That's a good thing. And after that, I will show it in a minute. We could change some boot credentials, some boot parameters, and put it in a root shell that we showed. So we've got this, type show, and then the last line is the most interesting. If we added that and placed that instead, and then boot it, we got this. Now we're in the device. So from that moment on, we had a Linux device and we needed to see or investigate what was going on, what was it doing when it was powered on. And we figured out that to use the internet, we needed to make some standard things. Can you read it? Okay. That's a little bit low. So. And these things were all done by the probe itself when it booted. It has some scripts, and it set some parameters. It made some files, and yeah, it's all dynamically. So we needed to get through those scripts and to reverse engineer what was going on. For doing this, we opened the scripts and we made some break lines in it to break the scripts while booting and to see what was changed after it. So we figured out that there were all kind of tools. That's the standard thing, /bin or /sbin, and there were some specific commands in home atlas /bin. We figured out that the SSH client made a phone home and connected with its probe key. Let's come back to that. To the Atlas server. So, like I said, we made a break in the probe boot up, and then there were some files generated which we could see. Let's see. What we then did is we had an internet connection, we had a location of the keys, and we wanted to get those keys. But since there was only a network connection on the probe, we needed to do some workarounds. Combustor had made this website, and we used the HTTP post command to post the probe keys up to the web server of Combustor. And this way we extract the private SSH key, which can be used for other good things, right? We also saw that we immediately got a firmware update, and we stopped the update process, and we HTTP post complete firmware as well, which can be used later on if we wanted to. There's only a strange thing going on. The firmware update was in big endian or in little endian, I don't know, but it needed to be the other way around in order to read it. A time ago, so I don't know for sure exactly what it was. But
it was big endian.
It was big endian.
You didn't need to mount it for.
Okay, so I changed it to the good one. Yeah, what we could do is when we opened the probe, then it did some things like connecting to the right service. What we wanted it to do, we just wanted it to know that nothing was going on. Just act as normal as you can. But on the same side, we wanted to log in on the probe as well. For doing it, we made an open telnet connection for the probe. We changed some boot-up scripts so we could enter it via telnet, and at the same time it could reach the internet as well. So we could look live what was going on. Later on, we used an easier way. Since we extracted the SSH keys as well, we could use a laptop from SYNNACK to make a connection with the same key as the probe did, and we could try to do some active stuff from our laptops. So what could we do with this? Well, since we could see what port was used, we could claim a port, we could claim a lot of ports, so we could create a denial of service. And that denial of service had a flick plus, because when we created a mapping from a port of the RIPE service to our own probe or our own laptop later on, all the other probes that wanted to connect and wanted to claim a port as well were rerouted to our device. So we could see what kind of credentials they use. We did not test it because we didn't want to damage the whole network or destructive testing it. So the DOS is actually used. Sure, we mapped a couple of ports and that worked. The password sniffing we didn't do. What we also could do is use the connection over the RIPE service to reach the other side of the internet. So we could send spam or look for porn or whatever. And all people think you came from RIPE.
You have the right ladies, right?
RIPE ladies, right? Yeah. We also tested that, just tested if we could log in on the RIPE service as well. And every time we tried to log in, we got the message, "You're not welcome." So after a couple of times, SYNNACK tried all kinds of standard passwords, and at RIPE they did a good job. On a certain point, we just typed in, "But trust me, I'm an engineer." And the RIPE server still was saying, "You're not welcome, you're not welcome, you're not welcome." And we were sick of it, so SYNNACK typed in, "I hate you." And then, "You're not welcome." Oh, well, after a time we quitted it, and we thought, well, we found some information that RIPE could use to make it better, to make it more secure. So Barry contacted the RIPE lady. What was her name? Vesna?
Vesna.
And we arranged a contact. We arranged a meeting to present our results. And one of the guys had a T-shirt with on the front side, I trust you, I'm an engineer, and on his back, "I hate you." And during the presentation, during the meeting, we were like, it looks so familiar, but you can't maybe. What's with the T-shirt? Why this? Well, the same night you called, we saw the log files, and we saw this. And then we knew, okay, there's those guys. So we printed it on a T-shirt. That was a very good thing. He had us up there. After the meeting, RIPE fixed the whole problem. Well, so they say. We didn't check it after that. But my probe, which we used for this, is still abandoned. It still is abandoned. And they say they would reactivate it, but not going to work.
And they're asking for you need to find a new exploit to activate it.
I guess so. This is just the news flash they posted on their website. So they say it's fixed. Well, a good thing. I think that this is one of the examples of a good cooperation. At last, I want to thank RIPE for doing such a great project. Together we can make this a little bit more secure, I think, and they give free hardware to us. Oh, that's a good thing, I guess. So, that's all. Maybe you have some questions. Just reference. later on. I think the slides will be posted on our website as well, Barry.
Yeah.
So, are there any questions?
Did you get a t-shirt?
I did!
Oh, that one.
It is.
Oh, okay. But not the trust me, I'm an engineer.
No. Yeah, that's, we wanted to, but well, we could print it ourselves.
Did you get a I hacked right, but all I got was last t-shirt?
No. We got this one, just the right project t-shirt. Very good one, special edition. Where's your probe?
So all girls are asking, where's your probe?
Yeah, I can't probe you. No.
Okay.
No.
No, thank you, but thanks for considering.
Yeah.
So long.
Any other questions, or?
So you reached the network. And
Yeah.
I wondered what so you could proxy over it. But
Yeah.
what else did you do? Any discovery of that network?
No, we didn't. No, we
Don't tell it. Don't tell it.
no, we didn't do any discovery on their side. We found out, well, okay, it's more or less satisfying. We could tell them right now, or we could go and investigate further and maybe break something. But later on we heard that they also have a testing network where we can do a lot more, and it's no big deal if there's something broken. And yeah, since the RSpliet network is an active network, we didn't want to damage it. So yeah, we could do scanning. That's no problem.
Yeah, it would be interesting. I mean, how much of the network you could discover, and how much information from that network that you discover,
Yeah.
you could then probably have escalated the problem and the severity of the problem, because you get into wherever the other probes could be.
Yeah, good point.
No.
Yeah,
the problem-
because of lucky guess right now.
The servers are located at HITR, the one we used for the proxying.
Yeah.
And those are just dedicated boxes, there's no network behind it.
Okay.
And the second thing is, if you break something in the RSpliet network which is not able to recover, then you got about 4,500 probes who are useless.
That's pretty good.
Yeah.
Sounds a good thing, right?
Well, there's fun about that, like unplug and replug and shit all work again, right?
It's
Would it be possible to form a back connection to another probe? Because then
yeah, well, not directly, but we could do it. Like I said,
we did it.
you can claim a port, you can claim different ports, and when a probe wants to connect with that port you already owned, claimed, and then it connects through the service right back to you. So you could get a port, and it's behind, because it's behind the encryption layer. You can just see. You can. That's no problem. Yeah, but what to do with it? That's
well, a back connection to 4,500 machines in different networks could be useful. But
could be useful. Yeah, but
Nicely geographically dispersed. That's the opportunity.
That's an opportunity, yeah, but we didn't want to do it.
no, of course.
It's a little bit of...
But if you're malicious, then
you could, yeah. And they say it's now not possible to reroute traffic over a probe, and it's not possible to reroute traffic from a probe over.
Did you verify?
No, like I said, no, so they say. Until not yet verified by us, by
there's
them.
a lot of probes. I mean, in this community, maybe you could set something up with the test network to see
but
if we can make that
as
happen.
soon as they see any suspicious network activity, they abandon your probe.
Yeah.
Yeah, and
And we do get access to the testing network of them,
Yeah.
so it's easier to go over there
Yeah,
and
indeed.
see what's happening.
yeah, they promised to give us some probes which are activated for a testing network, and break them.
Yeah. Cool.
So, are you going to continue your research with these things if you can't get into it anymore with yours?
No, with this probe I can't. Well, they promised a new probe. I don't know where they are.
Just ask a right messenger.
Master in our middle. I want a probe. Okay. And I want a special probe.
Okay.
Where do you want
Where do you want it, sir? Yeah. No, there, you know.
Into it.
No, and the only. So one thing to to say, let's see if I can start it again. We only tried it with the old pros, this one.
Which are way cooler.
Which are way cooler, and
Yeah.
they made them, developed them from within, I believe. They gave a company like money and they get hardware back or something. I don't know, they buy them, import them.
They cost like 60 euros.
Yeah, they're very expensive
Yeah.
for them, and they give them away for free. That's these are cheaper, and I think they're also easier to hack. But
They are.
yeah, exactly. Yeah.
If you connect the TTL to that one, you directly have root.
No, not anymore. No, firmware's updated though.
I have one that isn't updated.
Not yet, you know. Yeah, but then again, there has to be some kind of developer mode. So
There is.
yeah, so you have to boot it in that, and then things will open. Sets in the open.
Okay. Thank you very much, Ardillo.
Nice.